Assalamualaikum warahmatullahi wabarakatuh and a very good day. We are very excited today to share our unique NALI project called the Plant Designers 4.0. The project was initiated by 5 dedicated lecturers from the School of Chemical and Energy Engineering, Universiti Teknologi Malaysia. Dr. Haja Alias, myself Sharifah Rafidah, Dr. Jamal Rosliza, Dr. Ilyas and Dr. Yusuf.
As the Program Director for Universiti Teknologi Malaysia Chemical Engineering Program, it is always our goal to ensure that our current syllabus is relevant and following the trends of the industrial needs. The Plant Designers 4.0 project is one of our grand initiatives to upgrade our main capstone project, the Plant Design Project, to incorporate the latest trend, which is IR 4.0 and the 21st century 4C skills, which are collaboration, communication, critical thinking, and creativity.
The Plant Design Project SKTK 4834 is originally a normal project to design a single chemical process plant by students consisting of a team of 4 to 5 students, supervised by 1 academic supervisor. They basically have to use all the knowledge they have gained from year 1 to year 4 of their undergraduate study to complete this project. This year, we decided that we need to add more flavour to the project to make our students more relevant and competitive in the industries compared to the other chemical engineering graduates all over the world. So, we decided to introduce them to a new concept they have never heard before or even in any chemical engineering program. The Verbund concept. The Verbund concept is among the latest technology in the industry where multiple industries collaborated in an industrial symbiosis setting to exchange resources, maximize efficiency, reduce emissions and maximize profit. It has been utilized by global multinational companies worldwide such as BASF and Petronas to gain a competitive edge compared to their competitors. The objective of the new Plant Designer 4.0 projects are 1. To equip our students with the latest plant design knowledge. Secondly, to create a bigger scale collaboration level, which is inter-team collaboration with involvement of industry experts. Thirdly, to expose our students to IR 4.0 tools such as process simulator and other online tools. Fourthly, to provide them with a challenging design project that can push them to think critically and creatively. And finally, to create confidence in our students to communicate and present their work professionally to a vast audience.
What is this Verbund Plant Design Project and how did we execute the project to achieve all the objectives we mentioned previously? The methodology is divided into 6 phases. In phase 1, the project problem was crafted. A scenario was given where there was a call for competition by an oil and gas company for the best plant designers within Malaysia to design the next high-profit Verbund petrochemical plant. The company provided only the main raw material supply information and gave the team the flexibility to decide what downstream product they want to produce as long as it can give the highest profit based on the raw material constraints. They have to work inter-team to propose ways to integrate their plants designs together, maximize resource efficiency and reduce waste. They also have to design an integrated, centralized utility and waste management system. As this year, the project is done 100% virtual. A set of education 4.0 tools are used such as Aspen, Process Simulator, AutoCAD, Teammates, TeamViewer, Google Sheet, Padlet, e-learning, WebEx, Google Meet and Google Form. In phase 2, as the project is massive in scale, the main team is called a pool consisting of 20 to 25 students. Each pool have 5 to 6 design teams, each of which have 4 to 5 team members. Students are assigned to teams based on a combination of CGPA, gender, nationality and race. For each pool, A pool head and vice head are appointed to oversee project management and integration of all design project finding within the pool. A liaison officer is appointed for each design team to facilitate communication with the coordinators and pool heads. An academic supervisor oversees each design team. In addition, each pool has an expert panel for various fields of expertise for students to seek advice on, such as reaction, safety, separation system, process integration, and optimization. Each pool is also assigned with an industrial mentor with more than 10 years of design or operation experience. Students are provided with guidelines regarding the deliverables requirements for each evaluation. The evaluators are provided with detailed rubric for the marking schemes. The evaluation of projects are primarily divided into 5 sections. Evaluation by the academic supervisors on their complete design report, ethics, entrepreneurship, critical thinking, and problem solving. Peer evaluation for leadership and teamwork. Evaluation by coordinator based on their logbook. Design team and pool presentation evaluated by academics and industrial assessors. In phase 4, to support our students, 10 series of seminars led by invited experts from academia and industry will help to assist the students over 14 weeks period. To excite and motivate our students, the final presentation was made in competition mode with a grand award ceremony, where we gave award for the best teams and inter-team presentations worth RM1000. In the final phase, we gather feedback from our students and industrial mentors for future improvement.
Alhamdulillah, the project was completed by all of the students, delivering all the tasks assigned successfully. We compared the cost assessment report, CAR, for this semester and the previous semester. It was found that the results achieved are similar even with the introduction of the new Verbund concept. Nearly 95% of the students obtained excellent grades for this semester. From our post-mortem survey result, 91.9% of the students said that the Verbund project is a good idea and want to see it continuing in the future. 97% of the students agrees that industrial mentorship activities are great and should be kept up in the future. We are very excited to see the positive feedback on the impact of the project based on the student testimonial. Let's see some of it. Of course, in any teaching and learning, especially when it is first time a new concept is being implemented, there is a room for improvement. We received some minor negative comments due to the project tight deadline and online situation hindering project communication effectiveness. The Verbund or the Eco-Industrial Park concept has been researched by our team since 2014. 3 Q1 ISI journal papers have been published by our teams on the Verbund concept. We also developed software system for integrating industrial site resource known as Optimal Site and Trigen Site. Alhamdulillah, Optimal Site won the Silver Award in Pencipta 2015, while the Trigen Site won Special Awards and Gold Awards in MTE 2020.
To conclude, the revised plant design project has achieved its aim in incorporating the latest plant design knowledge, which is in trend and relevant to the current industrial needs. The project has also successfully incorporated the Education 4.0 and the 21st Century 4C skills. The project framework and guidelines has potential to be documented in a guided design project book to be commercialized and promoted to other chemical engineering universities. We hope this project idea can benefit more students in the future towards becoming the next generation plant designers 4.0.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.